in this video, we're going to discuss empirical formula. So, in problem letter A, find the empirical formula of sodium sulfite. Sodium sulfite contains a 36.5% of sodium and 25.4% of sulfur and 38.1% of oxygen. So, let's begin in letter A. So, in letter A, we have 36.5% of sodium. So in sodium, 36.5. So percent convert into grams. So grams of sodium. And how about in sulfur? Sulfur has 25.4. 25.4 grams of sulfur and 38.1% of oxygen. So in oxygen, we have a 38.1 grams of oxygen. So next step, you need to multiply by each molecular mass or formula mass are the same. So what is the formula mass of sodium, which is 23 grams of sodium times 1 mole of sodium. And here 32.06 grams of sulfur and 1 mole of sulfur. And this multiplied by 16 grams of oxygen and 1 mole of oxygen. So cancel out each grams. On the left is moles. So we need to calculate their moles. So 36.5 divided by 23 is equals to 1.5869 equals to 1.5869 moles of sodium. Okay. And next is 25.4 divided by 32.06 is equals to 0.792. 0.792 moles of sulfur. Okay. Equals 38.1 divided by 16. Divided by 16 is equals to 2.381. 2.381 moles of oxygen. So, which is the lowest moles? Which is the sulfur? So, this is the lowest moles. So, we need to find the ratio. So, let's begin in sodium. So, sodium has 1.5869. So 1.5869 and divided by the smallest moles, which is the sulfur, which is 0.792 equals, you need to divide that. So 1.589 divided by 0.792 is equals to 2.01. 2.01. And how about in sulfur? Sulfur has 0.792. So 0.792 divided by 0.792, which is 1. And how about in oxygen? In oxygen, they have a 2.381. And oxygen has a 2.381 divided by 0.792 equals 2.381 divided by 0.792 is equals to 3.01. So 3.01. So therefore, the empirical formula of this compound is equals to sodium has a 2 subscript. So sodium 2 subscript. And sulfur has a 1 subscript. 1 subscript. and oxygen has 3 subscript. So equals sodium sulfite. So that's your final answer. Okay, that is the empirical formula, which is the sodium sulfite. So how about in letter B? In letter B, what is the empirical formula of this compound, which contains a 53.73% of iron and 46.27% of sulfur? So let's begin. This is letter B. So in iron, they have a 53.73 grams of iron. And how about in sulfur? Sulfur has 46.27 grams of sulfur. So calculate by each formula mass. So divided by 55.85 grams of iron and 1 mole of iron. Then how about in sulfur? So 32.06 grams of sulfur and 1 mole of sulfur. So you need to cancel out by each grams. So the left is their moles. So we need to calculate their own moles. So 53.73 divided by 55.85 is equals to 0.9620. 0.9620 moles of iron. Okay, and 46.27 divided by 32.06 is equals for 1.443 moles of sulfur. Okay, and the lowest, which is the lowest mole, which is the iron. This is the lowest mole. So we need to divide by itself. So in iron, they have a 0.9620. 0.9620 is a 0. 20 over divide by itself, which is 1. And how about in sulfur? Sulfur has 1.443 moles. 1.443 moles of sulfur over 0.9620 moles of iron. So we find the ratios. So 1.443 divided by 0.9620 is equals to 1.5. So 1.5. So first of all, there is a decimal subscripts. Decimal subscript, which is multiplied by itself in 2. Equals, so 1 times 2, 2. 1.5 times 2, which is 3. So therefore, the empirical formula is equals to 1 times 2 equals to 2, right? And sulfur is a 3. So in iron, they have a 2 subscript. And sulfur has a 3 subscript. So that is the empirical formula. Iron 3 sulfide. Okay. How about in letter C? Right, in letter C, a hydrated compound has an analysis of 18.29% of calcium and 32.37% of, this is a chlorine, right? Chlorine, I forget. And 49.34% of water. What is the empirical formula? So let's begin. This is hydrates. So we need to answer this. In letter C, they have in calcium, they have an 18.29 grams of calcium. Then in chlorine, chlorine, they have a 32.37 grams of chlorine. How about in water? In water, they have a 49.34 grams of water. So we need to calculate by each molar mass, which is 40.078 grams of calcium and 1 moles of calcium. And how about here? We have a 35.45 grams of chlorine and 1 moles of chlorine. And here, they have an 18.02 grams of water times 1 moles of water. So we need to cancel out by itself, by its grams. So the left is their moles. So equals. So in 18.29 divided by 40.078 is equals to 0.4563. 0.4563 moles of calcium. Okay, and how about here? 32.37 divided by 35.45, which is 0.9131. 0.9131 moles of chlorine. How about in water? 49.34 divided by 18.02 is equals to 2.7380 moles of water, which is the lowest moles. The lowest moles is a calcium. So let's divide by itself. So in calcium, they have a 0.4563. 0.4563 divided by 0.4563 is equals to 1. And how about in chlorine? In chlorine, we have a 0.9131. So 0.9131 divided by 0.4563 is equals to 0.9131 divided by 0.4563 is equals to 2.01. So 2.01. And how about in water? In water, they have a 2.7380. In water, they have a 2.7380 divided by 0.4563. So equals 2.7380 divided by 0.4563 is equals to 6. Okay, 6. So the empirical formula, therefore, the empirical formula is equals to calcium has a 1 subscript. So in calcium, they have a 1 subscript. And in chlorine has a 2 subscript. Then in water, that have a 6 coefficient. So water. Okay, equals calcium chloride dot hexahydrate. Okay, so that is the empirical formula. So please like and subscribe.